Welcome to this presentation on register set and pin diagram of 8085. In this presentation, we will see the general features, the register set, flag register, pin diagram, and some practice questions on 8085. The main features: 8085 is a 8-bit microprocessor. That means it can accept and process 8 bits of data simultaneously. It has 8-bit data line. It has 16-bit address line, and hence it can access 64 kilobyte of memory. Additionally, 40-pin package, 5-volt power supply, and maximum frequency of 3 MHz. The figure shows a 8-bit register. Register in 8085 have 8 bits from MSB most significant bit D7 to LSB least significant bit D0. Registers are used to temporarily store data that is processed or to point to the address. Register set of 8085. It consists register A, also called as accumulator, a flag register, 6 general purpose registers B, C, D, E, H and L, a stack pointer that points to the top of the stack, a program counter that contains the address of the next instruction to be executed. The accumulator. It is a 8-bit register, also called as register A. It is the main register of the processor. It is mainly used for arithmetic and logical operations. In arithmetic logic operations, the first operand is always in A. After the arithmetic logic operation, the result is stored in A. General purpose registers. B, C, D, E, H and L are 6 general purpose registers. B and C, D and E, H and L can be used together, known as register pair. The valid register pairs are BC, DE and HL. HL pair is usually used for memory pointing. The stack pointer and the program counter. Stack pointer contains address of the memory location that points to the top of stack. The program counter contains the address of the next instruction to be executed. The flag register is a set of 5 bits that indicates the status after an arithmetic and logical operation. The sign bit S, the 0 bit Z, the auxiliary carry AC, the parity flag P, and the carry flag CY. The sign flag. It is set when the arithmetic and logical operation is negative. The 0 flag. It is set when the result of arithmetic or logical operation is 0. The auxiliary carry. It is set when the carry is generated from bit D3 after an arithmetic operation. The parity flag is set when the result contains even number of ones after an arithmetic or logical operation. The carry flag is set when carry is generated by an arithmetic operation. The pin diagram of 8085. It has crystal input pins, serial I/O, interrupt pins, address and data AD0 to AD7, the address pins A8 to A15, and the timing and control pins. VCC and VSS pins are used to supply the power to the 8085. X1 X2 pin is used to connect crystal to generate clock signal in 8085. The reset pin. It is active low. It resets the microprocessor when the pin is low for 3 clock cycles. Reset out. This pin is used to reset the peripheral device and other ICs on the circuit. This pin goes high whenever reset is given low signal. Pin AD0 to AD7. These pins serve dual purpose, the lower order address and data byte. During first cycle, this pin acts as lower half of the address, and the remaining clock cycles the pin acts as data bus. ALE signal is used to indicate address or data. A8 to A15. These pins carry high order address bus. The address is sent from microprocessor to memory. These pins are unidirectional. ALE, the address latch enable. This pin indicates whether bus function as address bus or data bus. If ALE is 1, then the bus is address bus. If ALE is 0, then the bus functions as data bus. RD bar. It is an active low signal. Low signal on this pin indicates read. Data is placed from memory location or input device on the data bus. WR bar. Active low on this pin indicates write signal. Data is placed from the data bus to the memory location or input device. IO bar. This pin indicates IO operation or memory operation. If pin is high, it indicates IO operation is performed. If pin is low, then memory operation is performed. The timing diagram. In the first clock cycle T1, ALE goes high, indicating the AD0 to AD7 lines contains the lower address. The IO bar is low, indicating a memory read. In the next 3 cycles, T2, T3, T4, AD0 to AD7 contains data. It indicates a read signal because RD bar goes low. It is a memory read because IO bar is low. In clock cycle T5, ALE is high, indicating the address lines on AD0 to AD7. The memory IO bar is low, indicating memory read. In clock cycle T6, T7, the data on AD0 to AD7. The RD bar is low, indicating read signal. The IO bar is low, indicating memory read. Clock cycle T8, ALE is high, indicating address. The IO bar is high, indicating IO operation. In clock cycle T9, T10, AD0 to AD7 contains the data. The RD bar goes low, indicating a read, and IO bar is high, indicating a IO read. Finally, the questions. How many bit processor is 8085? What is the address size of 8085? What is the register? Which are the registers in 8085? What is an accumulator? What are general purpose registers? Which register pairs are valid in 8085? What is register pair HL mainly used for? What is a flag register? Which are the different flags in a flag register in 8085? What is a stack pointer and a program counter? What are RD bar, WR bar and IOM bar pins used for? What are AD0 to AD7, A8 to A15 and ALE pins used for? Which pins are required for memory and IO operations? Thank you.